So in this video we're covering the multiple choice lecture of parallel lines and triangles. I will be talking about some of the examples here. I might split this into two parts depending on how much time we got left. So I'm going to do the triangles first. We've covered a lot of parallel lines, but clearly there's a lot of examples that you guys see here. In class we went through probably the first whole 16 examples and talked about them. But you have a bunch to try and you got the answers to look at. So I would highly recommend that you look through the parallel lines and do that. The main purpose of this video is going to be to talk about the congruent triangles. Again, we're looking at the assignment called multiple choice lecture. So I'm going to get to the congruent triangles problems. And we'll use these to talk about what's happening here. Okay, so we have a few ideas that are central to getting our congruent triangles problems done easily. All right? And those are what I call 1 second geometry. Right? They're really just diagram markings that you want to do kind of instantaneously. Okay, but through all the years, I've been calling them 1 second geometry because it takes 1 second to do, and if you don't do it, you actually might never do it. And so I've used this for many years to kind of emphasize the speed at which you need to carry these out and the ease with which you should do it. This shouldn't really be confusing, and so that means you just need to practice more. That's why I gave you guys all these examples. So there's like 30 examples for a reason. So the first one that we're going to talk about is marking common sides. Okay? This is very simple. It happens so fast. So if you're watching this video, pay close attention. Okay? We want to say, why are these two triangles congruent? We want to give it a reason. Okay? And we have the blue triangle and the red triangle. If you guys have highlighters, that can help you every now and then process what's going on here. So we have a common side. There is a side that is both red and blue, and it's right in the middle. So in order to mark a common side, this is what you do. You go like that. All right, I did it. That's how you mark a common side. You see how simple that is? So it could really be frustrating to teach this because it's so easy. So you want to be able to mark that that side is a side that's in both sides of this triangle. And then we're going to write the letter S, and we circle that to keep track that we have one pair of sides that are equal. Then we're going to start noticing the rest of our information. Okay, this angle is equal to this angle because they both have one arc. So I'm going to write the letter A and circle that to keep track of, hey, now we have two pairs of angles and one pair of sides. All right, the next thing I do is I see that this angle is equal to that angle. So I'm going to write the letter A again to keep track of the fact that I have another pair of angles. So now we should be able to look and understand the way that the angle-side angle postulate or theorem works, okay? The way it works is that the side should be in between the two angles, much like the way that the letter S is in between the two letter A's, all right? We need this to be a side that creates both of the angles, right? So we notice that S not only makes this angle, but also makes the other one, okay? So this question, we would choose B, and we would move on, okay? And again, this is true because both of these have the correct example, okay? They both use the included side, okay? So we'll talk more about that in a second when we get to the non-examples, okay? But again, this is our included side, and in the other one we had the included angle. So let's go take a look at 44. Okay, on 44 right here, again, we have a common side. So what we're going to do is mark that side very quickly, right? We're not going to wait for anything else to happen. We want to do that on the first thing that we do when we walk up to the problem. We should be able to say, oh, common side, boom. We want to mark that quickly, the second you walk up to it, okay? Because we're doing congruent triangles, and we just have to have that reflex. So this side is equal to that side. This side is equal to that one, okay? And like I said, this one was equal to itself, so you guys got to watch out for that, okay? And then this side with 3 marks is equal to the other one with 3 marks. So that gives me another S, and now I can read what my answer is. It must be side, 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 okay? So the thing about the side, side, side theorem that we've been trying to say, this means that if two triangles have the same sides, they have to be the same exact triangle, and there could be nothing different about them. So the thing is that a triangle is what's called a rigid figure, okay? What that means is that once you connect this, right, like if these were actually screws and like pieces of metal or something, right? if I was to put a screw, and if these black things represented pieces of metal, once I screw in these things in pretty tight, this triangle can't move. These angles can't change anymore. This is not going to be able to move around, okay? This would be totally different if I had a parallelogram shape, right? If I had a parallelogram shape and tightened these screws really tight, this shape could still deform a little bit, right? It would be able to flatten, for instance. If there was a lot of force on this, it could turn flat, and it would end up being more like that, and it would, maybe collapse if it was a structure. So what do architects and engineers do to make sure that that doesn't happen, right? That we don't have things that flatten and break? Well, we use a triangle, right? Because if you add a triangle in there, it stabilizes it by making sure that the angles can't change anymore, okay? And that's basically a consequence of side, 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 right? So if you have 3 side lengths, there's only one triangle that you can really make out of those side lengths, okay? And not every set of side lengths can be made into a triangle, all right? It's not always possible. So, right, if I had a side length of 1, right, and a side length of 1, and then a side length of 100, right, or even not, it doesn't have to be that big, right? What if it's 10, okay? I can't make a triangle out of those side lengths. It's not going to be possible, right? So, not everything can make a triangle, okay? But if I do make a triangle out of 3 sides, there's only one that I can make. So, side, side, side is kind of an important one. And it's also really easy to see because you don't have to worry about anything else. You're just looking for 3 pairs of sides. All right, in this example, we finally get to something that's not a common side. So now we're going to get the second list of our 1-second geometry. Okay? So again, the 1-second geometry that we had was marking a common angle. Okay? That was the first one. In this case, sorry, not marking a common side. Okay? We don't have a common side. In this problem, we don't. There's no side that is in both triangles here, right? If we consider this to be the blue triangle, and we consider this one to be the red triangle, there's no side, you see, that is in both of the triangles. None of those sides is both red and blue. We do see this point that got kind of colored red and blue, so we'll talk about what that's going to mean, okay? So marking common sides was the first one, okay? Right now we're going to talk about marking vertical angles. Okay, so this is something that you really want to have as a reflex. It's one of the first theorems that we're going to learn how to prove. And you got to be able to do it from scratch because it helps you with so many other things. So marking vertical angles is something that I'm going to do very quickly. We already did 1 arc, so now I'm going to have to use 2 arcs to make these marks. Okay, so to mark the vertical angles is to mark this one and that one. Okay, so that really took me about 1 to 2 seconds, right? So that's why we call it 1-second geometry. Now let's go label our pairs of information to keep track of what we got, okay? I have that this side is equal to that side, so I could write the letter S. We have that this angle is equal to that angle, so I'll write the letter A. And this angle is equal to that angle, so we have another pair of angles, okay? We should be able to see right here that we have the angle side theorem, but we also want to double check that this is done correctly because angle side uses a side that's not in between the 2 angles. So notice that this mark is not in between those 2 angles right there. And so that's why we don't have angle side angle. And notice the same thing is also happening over here, right? Like this mark right here is not right there. If that mark was in this spot right there, then we could say that that was going to be not enough information, okay? Because again, both of them have to have the side outside the angles, right? So we want to make sure that both of them are angle side. So in this case, we got angle side. Okay. Now the next thing we got to do is talk about non-examples too. So in this case, you guys should mark the common side in the middle right here. And if we mark that common side, we will see that we have what we need to get, which is a side angle side example again. Okay, this side is equal to itself, so we put an S. But this side is equal to that one, so that's an S. And this angle is equal to that one, so that's an A. So we can see side angle side, but we also want to check that both of them are side angle side. Like notice here, these 2 sides make the angle. Okay, let's go double check the other one to make sure that that's also what happens. Okay, and then these 2 sides that are equal also make that angle that's equal. So this is a true example of side angle side. Okay, doing these little marks is the most important thing because that's the main thinking that you have to do. So we just have to do a lot of repetitions so that you guys get used to it. So this next one that we have for 47, you would mark the vertical angles. If this is 90, then that means this is 92, and obviously they're both the same. So in this case, we can kind of use the right angle block symbol as something to mark those two angles equal, because they have to be the same anyway. So this side is equal to that side, so that gives me an S. This angle is equal to that one, so that gives me an A. And this side is equal to that one. So I have another side. Let's make sure that we actually have the sides in the included angle. All right, these two sides make that angle, and these two sides make that angle. So this is a true side angle side example here. Okay, if anybody sends me an email, I would be able to get you more practice on these. So just let me know. I'll add that to Google Classroom. If anybody asks me, even one person, I'll make it for you. All right. So on number 48, we have a common side. And if we put it here, we should be able to see that that's the included side from both of these angles, right? This side in the middle is in both of them. So our answer here is going to be angle side angle, okay? And you should be able to start getting these a little quicker, all right? The only thing that makes me nervous is that sometimes there's not enough information. And we haven't quite got there yet. So let's see number 49. What do we have here? We have these two sides are meeting in this point at the vertex of that angle, and so are these two. So you guys should be able to recognize that this is a side angle side just by looking at it after maybe 30 seconds or something. Okay, number 50. So here we have a vertical angle that we should deal with, right? We want to go mark that down and finish up the problem. So let's talk about marking a vertical angle. Okay, we already used one mark, so now I'll use two. So those two are equal to each other. Okay, now we just mark up our paper, right? This angle is equal to that one, so I'll put the letter A. This side is equal to that side, so I have an S. This angle is equal to that angle, so we have an A. So now we can see that we have angle, side, angle, and as we've been saying, the side has to be in between the two angles, and look, it literally is. All of this information comes from one line, okay? So I repeat, in angle, side, angle, all the information you're going to see on one line right there, okay? So we only label one of the triangles, otherwise you guys will get confused. So what you got to do is pick one of the triangles to label with your ASA, and then only label that triangle. In this case, you can see I started labeling the blue one, so that's the only place where I wrote the angle and side pairs. Next we'll move on to number 51. Okay, so for 51 here, we got some problems to deal with. We have another vertical angle. So if we're going to mark this vertical angle here, we can see these two are equal. I got that angle equal to that one, this side equal to that one, and this angle equal to that one. So we can see that I have achieved angle, side, angle. And again, notice that both of these triangles have all the information right there on the straight line. Okay? So the next thing that I'm going to do is basically just keep moving through. All right, let's see if we can get an example. I want to catch one that has not enough information. Okay, so here on 52, you should mark the common side right in the middle. If you mark that common side, you should be able to see that we have 3 pairs of common sides now. So 52 would be side, side, side. Okay, also notice that we don't know anything about any of the other angles. So that would tell us that we could cross out A, B, and D. Okay, in this case, again, look, we have nothing but sides. We don't know anything about the angles. So we would have to pick side, side, side. All right, 2 triangles have 3 pairs of corresponding sides. Those triangles are the same. All right, for 54, we can see that we have an angle, angle side in this case. So it's slightly different, right, than angle, side, angle. So,
Did you just jack this seat?
I'm almost done with the video. Can y'all keep it down for just a second? I'm gonna finish this up. This is getting kind of crazy. I gotta lock people out. Let's go get it. All right, here's the last one. Then I'm gonna keep the door locked for like a minute. So I just gotta finish this video. All right. Jesus Christ, where are y'all? Turn this from. Dude, how the hell did y'all get me so fast? All right. Don't let anyone in, nor should anyone say a single word. Okay, I'm going to be highly offended if you guys talk right now, or if you cuss while I do this. You understand me, bro? Okay, please do not cuss, or you're going to ruin 20 minutes of work that I just did. All I need is you guys to be quiet, and we're all good. Like I said, I'm going to be a little offended if you guys start talking. Okay? Bro, give me 1 minute. All right, give me 1 minute. All right. So, to complete this one, we should see we got angle, angle, side, because again, the side is not the included side. So let's move on to the next one. We got another side, side, side example. That one's too simple. Let's take a look at what we need right here. Okay, we got another angle, angle, side example. What I really want to do is get someone that's not enough information, and it looks like 63 is the first one we can talk about. Okay, so on 63, let's break down why this cannot be done with what we have. And this will conclude the video. Alright, notice that we're going to mark this common side really quickly, and then we have this side is equal to itself, this side is equal to that other one, and then you might have a false side angle side, because it looks like that angle is equal to that one. So on top of everything that we do, we should analyze this here and notice that there is no side angle side. So that's one clue that we have, okay? But even if we didn't do that, I want you guys to realize that these two sides make this angle, okay, that is an acute angle. Whereas these other two sides are making this obtuse angle, and that's not the same corresponding angle. Okay, so because we don't have the included angle, I basically wanted this little mark that's right here, we wanted that mark to go right here. Okay, and that would have let me use side angle side. Since that mark is not there, we have not enough information.
Andrea Rio, please report to the attendance office.
Again, because that mark is not there, we have not enough information, so we can't conclude that it's side angle side. All right, so that concludes the video. I hope you guys can practice these. Let me know if you got questions.